Into the Unknown, Above and Below by Stuart Ross. Illustrated by Stephen Beastie. The layers of Earth's atmosphere. Outer space. Thermosphere. Scorchingly hot. 12 times boiling point. 32 times human body temperature. Around 50 miles up. Mesopause. Temperatures here can fall to negative 150 degrees Fahrenheit. Mesosphere. Temperatures as low as the lowest ever recorded on Earth. Around 30 miles up. Stratopause. Temperatures can rise to 32 degrees Fahrenheit. Stratosphere. Not enough air for breathing, and temperatures as cold as at the poles. Around 10 miles up. Tropopause. Completely dry. Troposphere. Wet and oxygen-rich. The Earth's surface. By the early 1930s, explorers had traveled to every corner of the Earth and mapped nearly all its land surface. Some said there was nowhere new to go. However, many remote places remained that had not yet been visited. Who knew, for example, what lay in the stratosphere, that vast blue canopy above the clouds? Or what lurked in the depths of the deepest, darkest oceans? Were there monsters there? Manned balloon flights had already risen to the lower reaches of the stratosphere, and recently invented submarines had dived 900 feet or more below the surface of the sea. But such journeys were extremely dangerous. The air is so thin in the stratosphere that there is not enough oxygen for breathing, and human bodies collapse. Equally terrible, in deep seas, water may weigh a crushing 8 tons per square inch, enough to squash an ordinary submarine like an empty soda can. One family faced these dangers and triumphed. Auguste Piccard and his son Jacques were among the bravest explorers of all time. Unlike adventurers of the past, they were not steely soldiers or hardy mariners. Rather, they were scientists. Vast. Something vast is very large. Mariners. Mariners are people who navigate ships, such as sailors. Swiss-born Auguste Piccard, born 1884, died 1962. Studied engineering in Zurich before becoming a professor of physics in Brussels, Belgium. There, he grew interested in new theories about the cosmic rays that were believed to be active in the stratosphere. To learn more, he decided to go and observe them directly. In those days, the stratosphere was beyond the reach of any airplane, so the only way to travel there was by balloon. In 1862, scientists James Glaisher and Henry Coxwell had risen more than 6 miles in a balloon. In 1912, Victor Hess, the scientist who discovered the existence of cosmic rays, had reached over 3 miles. But all 3 had nearly died in the process. So how could Piccard ascend to 7.5 miles as he hoped and still return safely to Earth? Backed by Belgium's FNRS, National Fund for Scientific Research, Auguste constructed a remarkable balloon. Its enormous canopy was made from very light cotton, sealed with a thin coat of rubber. To make it rise, the canopy was inflated with lighter-than-air hydrogen. To descend, the crew pulled a cord to release hydrogen from the top of the canopy, making the whole balloon heavier. Cosmic. Something that is cosmic is beyond Earth and its atmosphere. Ascend. To ascend is to go up. Below the canopy hung a lightweight aluminum sphere. This specially designed cabin, with 8 tiny portholes and 2 hatches, was just large enough for a 2-man crew and their instruments. Once the balloon had risen to 5,000 feet, the hatches were sealed and the cabin became airtight, so the pressure inside remained constant no matter how high the balloon went. The same principle applies to the pressurized cabins that are standard on all modern high-flying passenger aircraft. In order for Piccard and his assistant to breathe safely, the cabin was equipped with around 10 hours' supply of pure oxygen and a system for recycling stale air. On May 26, 1931, the FNRS, the balloon was named after its sponsor, lifted off from Augsburg, Germany. Up and up and up it went, climbing into the stratosphere. Amazingly, some 17 hours later, it floated safely down again and landed in the Swiss Alps. On this first flight, Piccard and his assistant, Paul Kipfer, had reached a world record 51,775 feet. However, an air leak and the tangling of the hydrogen release valve had made it too dangerous to gather any scientific data. Principle. A scientific principle is a rule that explains how something in the natural world works. Inside the gondola. Crossbar, for sealing and unsealing hatch. Hatch, sealed shut at 5,000 feet. White painted aluminum gondola. Auguste Piccard. Porthole. Altimeter, measures height above ground. Oxygen tanks. Food for flight. Lightweight wicker seat. Radio aerial, lowered from hatch. Line. Operating hydrogen release valve at top of canopy. Ring for attaching the gondola to the canopy. Support ropes. Second hatch. Max Cossins, wearing padded helmet for protection and warmth. Statoscope. Measures rate of climb. Barometer. Measures pressure inside gondola. Electric batteries. Ballast release mechanism. Ballast released through airlock. Tank storing 5 million tiny lead spheres of ballast. Carpeted wooden floor for warmth. Iron mercury-filled U-bond houses line from hydrogen release valve. Release valve handle. The following year, the FNRS flew again. This time, Auguste was accompanied by a Belgian engineer, Professor Max Cossins. On August 18th, they drifted high above southern Switzerland and northern Italy, crossed Lake Garda, and landed near the Italian resort of Desenzano. This time, all went well, and they were able to make the scientific observations they needed. What's more, they beat their own record, reaching an amazing 52,152 feet. The path of Auguste Piccard's second flight into the stratosphere. A further 25 ascents followed over the next few years. Piccard pushed the world altitude record to 72,177 feet and gathered vital information about the stratosphere and those strange cosmic rays. As it turned out, they were not rays at all, but minute space invaders, subatomic particles zooming into Earth's atmosphere from elsewhere in the universe. By the time of his last balloon adventure, Auguste Piccard knew that the principles of his pressurized cabin could also take him to the depths of the ocean. Working with his son Jacques, he began to design an extraordinary deep-sea craft, or bathyscaphe. They named it the Trieste. Instead of a balloon canopy, the Trieste had a long cylinder-shaped float. Inside the float were a large gas tank and 2 air tanks. Gasoline and air are lighter than water, so when all 3 tanks were full, the craft remained on the surface. To make it sink, the air tanks were flooded with seawater. The float also contained two hoppers filled with iron pellets to release when the bathyscaphe needed to rise again. An airtight cabin was welded beneath the float. Like the cabin of the FNRS, it was a perfect sphere, but instead of aluminum, its walls were forged in steel 5 inches thick. It had two windows made of strong artificial glass called lucite, and it had an air supply and purification system that allowed two crew members to breathe safely for up to 24 hours. Built in Italy, the Trieste was bought by the U.S. Navy in 1958. The following year, the freighter Santa Maria transported it west from California to Guam. The USS Wandang then towed it to a site above the deepest part of all the world's seas, the mysterious Challenger Deep. Forged. A metal object that was forged was heated in a special furnace and hammered into shape. Piccard and Walsh recorded the depth of water under the Trieste with an electrical device called an echo sounder. Key. 1. Transmitter sends sound waves down to the bottom of the sea. 2. Sound waves hit the sea floor and return to the transmitter. 3. Receiver picks up sound waves coming up from the bottom of the sea. 4. The time difference between the sound transmitted and the sound received is measured electronically, giving the depth. To the ocean floor. At sea level, Trieste's air tanks are flooded with seawater and she begins to sink. 325 feet below, Piccard releases gas to allow Trieste to descend through a cold layer. 985 feet. Arc lights are switched on. 1,970 feet. Speed of descent now increases from 4 inches per second to 36 inches per second. 2,400 feet. Total darkness from here on down. 18,000 feet. Cabin springs a leak but seals itself. 23,000 feet. Trieste sets a new record for the deepest ever dive. 27,200 feet. Piccard dumps some ballast to slow the rate of descent. 30,000 feet. Alarm sounds as outer window pane cracks. 31,000 feet. Piccard uses echo sounder to detect bottom of trench. 36,000 feet. Trieste comes to rest on the bottom of the Challenger Deep. Water pressure increases with depth. At the bottom of the Challenger Deep, the total pressure on the Trieste was 220,500 tons, 1.24 tons per square centimeter, equivalent to the weight of 5 A380 Airbuses. The Great Gash in the Earth's surface, deeper than Mount Everest is high, lies in the Mariana Trench on the floor of the Pacific Ocean. Here, in rough seas, Jacques Piccard and Lieutenant Don Walsh of the U.S. Navy undertook one of the most nerve-rattling journeys ever made. On the morning of January 23, 1960, the two men climbed through the hatch and sealed themselves into their steel bubble. At precisely 8:23 a.m., they let seawater into the air tanks above them and began a 288-minute descent down to the funeral black floor of the ocean. To Jacques' surprise and dismay, at about 340 feet below the surface, the Trieste came to a stop. It had met a dense layer of cold water, a thermocline, which blocked their descent. After a quick calculation, he made his craft less buoyant by releasing some of the gas from the tank above, and the Trieste continued dropping into the darkness. At 1,000 feet, Jacques tested the Trieste's quartz arc lights, casting bright white beams into the surrounding sea. Plankton streamed past. By 2,400 feet, they had moved from the twilight zone to the abyssal zone, where not a trace of sunlight can reach. Staring out at the grim blackness, the men felt the cabin grow colder and colder. Around 18,000 feet, the cabin sprang a small leak, which a little later mended itself. Now dropping at 200 feet a minute, the Trieste plummeted beyond 23,000 feet, reaching a new record depth for any dive. At 29,500 feet, Jacques could feel the steep walls of the Mariana Trench rising around them. The Trieste had not been tested to this depth, and he released some iron ballast to slow her speed. The ocean floor was still about a mile away. Suddenly, the men were shaken by what sounded like a muffled explosion. The outer skin of one of the windows had cracked. For a second, they thought they were finished. Luckily, the inner layer of lucite held fast, and not long afterward, the Trieste came to rest at the bottom of the Challenger Deep. Switching on their lights again, they stared out in wonder at the fish and slime around them. It was certainly eerie and strange, but at least there were no monsters. As it would be dangerous to surface at night, the Trieste could not stay long. After just 20 minutes, Picard lightened his craft by releasing 10 tons of iron pellets from the hoppers in the float. The Trieste immediately began to rise. Faster and faster she climbed, until she was moving upward at 5 feet per second. Just over 3 hours later, she broke the surface of the warm, bright Pacific. The sailors on the Wandank and the escorting destroyer Lewis hurried to winch her from the water and release her crew. The amazing Picards are still the only explorers to have traveled literally to both the heights and depths of our world. Voyage to the Deep. 1. The Santa Maria carries the Trieste from San Diego to Guam. 2. The tug USS Wandank tows the Trieste 250 miles west from Guam. 3. Trieste position at dive site. 4. On the bottom.